Hi guys, so this is the second day of 3-6, and before we get going on the new content, we're going to have you run through a couple warm-up problems. So if you could do me a favor, go ahead and try these warm-up problems out, and when you're all set and ready, start the video up again, and I'll have the answers there for you. Alright, so taking a look at the first one, it said find the x and y intercepts of the following line, 2x plus 4y equals a negative 8. And when you're finding the x and the y intercepts, remember from the previous lesson, is find x intercepts. All you have to do is throw a 0 in for the y's that you see, and then solve. So that's what I did, and I ended up getting a negative 4. So as a point, the x-intercept is a negative 4 comma 0, because I threw a 0 in for my y. Doing the same thing for the y-intercept, but this time you're going to throw a 0 in for the x's that you see. So I solve for my y, and I end up getting a negative 2. So my y-intercept is 0 comma negative 2 because I threw a 0 in for my x. In number 2, it said write the equation of a line in slope-intercept form with a slope of 3/4. Oh, I think there's a negative there, and there is, so let me go ahead and add that in real quick. Negative 3/4 and a y-intercept of 2. So remember, with a slope-intercept form, slope-intercept is y equals mx plus b. The m is my slope, and I missed my x here. Good job. Way to start this lesson. So I've got y equals a negative 3/4 x plus 2 because my y-intercept was 2. Here's another warm-up problem. Once you go ahead and try this, you're going to write an equation of the line through the 2 points in point-slope form. Try it out, and when you're set and ready, go ahead and start the video again. Alright, so taking a look at this problem, hopefully you realized if you're writing it in point-to-slope form, you need two things. You need a point, and you need a slope. So if I know that I've got 2 points here, I've already qualified the point part. I don't have to worry about that. The slope is the issue. So the first thing you needed to do was actually find out what the slope between those 2 points was. So I figured it out, and I ended up getting a 1. So now that I've got my slope as a 1, I can now pick either point and write it in point-slope form. So I did both of them just in case you chose one and not the other. So if I were to choose the first point, and it doesn't matter which point you choose, but if I were to choose the first point, it would have been y minus the y coordinate. So y minus 0 equals the slope of 1, and then x minus the x coordinate. That's why it's minus the negative 1, so it turned into a plus positive 1. What if you pick the second point instead? No problem. We can pick the second point. That's not an issue. So we ended up getting y minus the y coordinate of 2 equals the slope x minus the x coordinate. The last warm-up I want you to try is I want you to go ahead and try to graph the following lines using our information that we learned from the previous day. So go ahead, try to graph these out, and when you come back, we're going to take a look and see if your lines match my lines. Alright, so let's go ahead and take a look at the first example. We've got y equals 1/2 x plus 1. I notice that it's written in slope-intercept form, so I can pull not only the slope from this, which is 1/2, but also a y-intercept of 1. And if it's written in slope-intercept form, go to your y-axis, plot your y-intercept at 1, and then my slope was 1/2, so that meant I went up 1, right 2, up 1, right 2. The next equation was written in point-slope form, so I could pull two pieces of information from it. I could pull the point, and I could pull the slope. So our point was a negative 4, 3, pulling the x-coordinate and then the y-coordinate, and our slope was a negative 2. So when we graph this out, I'm going to graph the point first. So we're going to go to negative 4 up to 3. That's my point, and my slope was a negative 2. So down 2, right 1, down 2, right 1. In the next one, y equals a negative 3, you have to remember that a y equals equation is indeed a horizontal line. So we've got a horizontal line at negative 3, and an x equals 2 equation was it's a vertical line at x equals 2. So any of the points that I have sitting on this line have an x coordinate of 2. So let's talk about pairs of lines. What happens if I give you two sets of equations? You can actually tell me if those two lines are going to be parallel, intersecting, or coinciding. Let's talk about parallel for a second. You do know that lines are parallel when they have the same slope. Now, the issue that we have is with parallel lines, they are two coplanar lines that never intersect each other. So in this case, if we were talking about parallel lines, yeah, they'd have the same slope, but they would have to have different y-intercepts because they're not allowed to touch each other. So parallel lines have same slopes, different y-intercepts. If we talk about intersecting lines or lines that cross over each other, you would realize that they do not have the same slopes. They actually have different slopes. So if I'm working with two equations that have different slopes, then I know these equations, the lines would be intersecting. The last type would be if we're working with lines that have the same slope, you might say, oh, they're going to be parallel. But what if they have the same slope and the same y-intercept? Hopefully you realize that you're actually working with the same exact equation. So I could have a line drawn for the first one, and then the second one gets drawn right on top of that. And when that happens, when we're talking about the same exact line, essentially, we call them coinciding. So the same slope, same y-intercept. So what we're going to do is we're going to go through a couple examples and we're going to determine whether the lines are parallel, intersecting, or coinciding. So the first example says y equals 3x plus 7 and y equals negative 3x minus 4. So when I look at these problems, the first thing I'm going to go to is the slope. Now I'm looking at the slope in both of these lines, and hopefully you notice that these slopes are different. As soon as I notice that the slopes are different, that means that they cannot be parallel and they cannot coincide, therefore they are just intersecting. So these two lines intersect. Go ahead and try the next example out on your own. So take a look at this one. Notice that the first equation was written in slope-intercept form, but the second was not, so the easiest way to go about this is to go ahead and get the y by itself. So I divided everything by 6, and I ended up getting y equals negative 1/3 x plus 2. So now when I answer the question, is it parallel, intersecting, or coinciding, first thing we do is we take a look at the slopes. And the slopes of these two lines are indeed the same. So that means they're not intersecting. They're going to either be parallel or coinciding. So the last thing you have to take a look at is the y-intercept. They have different y-intercepts. So if they have different y-intercepts with the same slope, we consider these lines to be parallel. All right, last example with the parallel, coinciding, intersecting. Why don't you go ahead and try this out on your own and see what I get for my answer in a couple seconds. So, taking a look. Hopefully you realized yet again we have two equations of lines that are not y equals, so the best route is to get them to be y equals equations. First equation, what I did was I added the 4x to both sides, and then I divided by 2. So I've got y equals 2x plus 8. The next equation, I first distributed my 2 through, and then I added my 10 over. So I'm looking at these two equations. First thing you look at is the slope. So I'm looking at the slope of the two lines. I notice that they're the same, so it's either going to be parallel or coinciding. So the next part you look at is the y-intercepts. And notice the y-intercepts are the same. So same slope, same y-intercept means that these two lines coincide. Hopefully that's spelled right.
Alright, you guys, in this next example, it asks you to write the equation of a line that is perpendicular to y equals 2x plus 3, and it goes through the point 1, negative 2. Okay, so there's a couple different things going on here. The first thing is that we're talking about lines that are perpendicular. First thing that pops into your head is, if the lines are perpendicular, their slopes have to be opposite reciprocals. We also know that we have a point. So let's take a look here. The opposite reciprocal of a 2 would be a negative, because this is positive, so this would be negative, that's the opposite. The reciprocal then would be 1 over 2. So here's my slope, and here's my point. This is what I have to work with. Well, it just so happens that you guys should know how to work with points and slopes using the point-slope formula. So to write the equation, remember it's y minus y1 equals m times x minus x1. Let's plug in our point. Y minus a negative 2 would be plus 2 equals negative 1/2 times x minus 1. Okay, so what we're going to go ahead and do is I want you to actually solve and make it a y equals mx plus b form. Okay, so from here, to get rid of this silly little fraction, I would multiply both sides by 2. Okay, leaving it 2y plus 4 over here. Here, remember, because of the multiplication, the 2's just end up canceling each other out. So you end up with negative 1 times the x minus 1. So now you distribute to get negative x plus 1. We're going to subtract the 4. That gives me the negative 3 here, and then divide everything by 2. So your equation is y equals negative 1/2 x minus 3/2. Remember, we knew it was perpendicular, so that's where I got my slope from, the opposite reciprocal. Then I had a point and I had a slope, so I used my point-slope formula to get my actual equation. All right, this next one says to write an equation of a line parallel to this equation that goes through this point. Very, very similar. If they're parallel, however, we know that their slopes are the same. So I'm going to have to manipulate this equation to find my slope. So that's what I would like for you to do first. Find the slope of this line and find the slope of your new line, please, and then come back. All right, what you should have noticed is with this equation here, I moved the 6x over, and then I divided each one by a negative 3, and I got y equals 2x minus 3. So the slope of this line is 2, and if I want the slope of the parallel line to it, it would have to be the same. So my new slope is 2. So now I have a point, I have a slope. I would like for you to use the point-slope formula to help you actually find the equation. Okay, so you have your point-slope formula. Remember, we take y minus the y coordinate. In this case, it's 3. And then your slope. And then x minus the x coordinate. Now minus a negative 5 gives me plus 5. So then I distributed the 2 and I added the 3 to get me my equation. So this line is parallel to this one. Remember, we found our slope because they were parallel. That's my new slope. Here's my point slope formula, and then we solve. Okay, so in this case, they want you to use the description to graph each line. I'm going to do A, I'm going to have you do B, and then we're going to come back together later. So, in part A, it says, I want the line that's parallel to this one. And, oops, sorry, you guys. I want the line that's parallel to this one, and it goes through this point. Well, remember, if they're parallel, we should have the same slopes. In this case, the slope of this line is 3, which makes my new slope 3 as well. So, I know I go through this point, so I'm going to plot the point 1, negative 2. And then I also know I have a slope of 3. So from that point, I'm going to go up 3 and over 1, up 3 and over 1, and then I could draw my line. I would like for you to do B, please. Remember, I want a line perpendicular to this graph through the point. All right, so hopefully you notice that your slope here is 2. If they're perpendicular, they have to be opposite reciprocal, so the opposite reciprocal would be a negative 1/2. So I'm going to plot my point at 2, 0, and then go down 1 over 2. Or you go up 1, back 2. Either way, this is the line you should have gotten. All right, I'm going to do C, and I'm going to let you do D, just like we did with A and B. In C, it says I want to be perpendicular to the y-axis through this point. Well, let's see here. The y-axis is a vertical line. Vertical lines are undefined. So if I want to be perpendicular to that, that means I have to be the opposite reciprocal. We're looking for a horizontal line. So that means my slope is going to be 0. So I'm going to go through the point 4, negative 3. So let's graph this point 4, negative 3. Oops, sorry, it's negative 4, 3, you guys. Good thing I stopped. Negative 4, 3. So there we go. And I want a slope of 0, which means it's going to be a horizontal line. It's going to look like this. I would like for you to do D, please. I want it to be parallel to the x-axis, going through the point 5, negative 2. All right, parallel to the x-axis. Well, the x-axis is a horizontal line, which means the slope is going to be 0. If they're parallel, they have to have the same slope. So this slope also is going to be 0. So I go through the point 5, negative 2, so I'm going to point the point plot the point 5, negative 2, and then my slope is 0, so you have a horizontal line. All right, you guys. Hopefully you got the concept, you got the grasp of this parallel perpendicular business. I would like for you to make sure that you write some good questions down in your WISC, and we'll talk to you tomorrow.